And and here we go. So welcome, everyone. We are looking at this, I think it's the last presentation this year, at least for the pilot in the science curriculum for kindergarten. It's the energy organizing idea. And before we begin, though, what I would like to do is just, what's going on here now? I'm not able to move forward here. There we go. I'd just like to just take a moment to acknowledge our territory and our land here. And I'd like to begin that way by playing a short video by Stephen Paquette. He's an elder. And before I read our land acknowledgement, I would really like to provide an opportunity to hear what Stephen has to say about land acknowledgements.
What I've learned from my elders is that when we do acknowledgement of the land, it's not about acknowledging whose land it belongs to, because that indigenous worldview, we never owned the land. We were simply caretakers of it for future generations. And what I've been taught from my elders is that when we do that acknowledgement of the land, it's much more than just the territory. It's about relationships. It's about our relationships with people that share the land. It's our relationships with Mother Earth. It's our relationships with the four-legged, the finned, the feathered, the crawlers, the original stewards of Mother Earth. It's that relationship that we acknowledge with the trees. It's that acknowledgement that we have with the plant life that is part of the food chain and helps us exist. It gives us our medicines for healing, gives us food for nutrients. It gives us our medicines for ceremonies. We acknowledge water. Water is sacred. Water is life. And what we're told is that when we acknowledge that water, that we always have to acknowledge the carriers of those teachings, which are the women. So we do that in the same voice. We also acknowledge the infinite wisdom of the grandfathers. Then we take that to the next level, is which acknowledging that relationship that we have with father-son, or in some nations, brother-son. We acknowledge that relationship that we have with Nokomis, Grandma Moon, and how she cleanses Mother Earth. We acknowledge that relationship that we have with our distant relations, the star people. So when we talk about acknowledging the land, it's so much more so than just acknowledging what nation was on that. As we know all throughout the history of Turtle Island, is that indigenous people were, for the most part, nomadic people. They shifted. They would move from season to season. It just so happens that Sheridan sits on the treaty territory of the Mississaugas of the Credit, which I'm very proud to always share and educate with people. But in the same breath, I also acknowledge that many, many other nations have walked this territory, and that their ancestors are still here amongst us.
I do like hearing Stephen, and especially his little comments on the acknowledgements of land. It is much more than just saying it is a place where people used to live. It's a place where relationships are built. It's a place where we live and work together. And with that, I would like to read just a brief our land acknowledgement. I am coming from Treaty 6. So it is in the spirit of reconciliation that we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse nations, Métis and Inuit people, or Métis and Inuit peoples. We acknowledge that this land is a traditional meeting ground for giving voice to its original peoples and the story of creation of this country in a way that history have forgotten. With that, welcome everyone. As I mentioned earlier, may not have been here. Fortunately, Chris cannot be here today, but she does have a section that is recorded that we'll play later. And when we get to that point, we can you can decide whether you can stick around for that or get the recording later. Now I'm having a little bit of difficulty getting to my slides. There we go. We'd hope at the end of the session that you do feel a little bit more confident in moving forward with this organizing idea. It is, when you take a look at it, a relatively short one, and the concepts and ideas in it aren't overly burdensome, and it can be a fun one to do. So we hope that at the end of the session, feel confident in moving forward with that organizing idea, and that you have a sense of direction moving forward, not only with this organizing ideas, but next year, as we know, there's some implementation going on, and give you some direction and sense of efficacy as you move forward with the new curriculum and the planning. Their agenda today is to do want to take a closer look at the cusps. Now, it's difficult to work with this front end. I'm not too sure if everyone has been here at the other sessions or not. And so there's always a little bit of a repeat. I'm trying to change it up a little bit in case there are people who are continually with us. But because of the nature of the pilot, where teachers could implement two of the organizing ideas, might have missed some because we're not doing the computer science organizing idea as a presentation. So bear with me as I go through the front end part, and I will try to make it a little bit different or move through it maybe a little bit quicker than we have, so that if you've heard it before, it won't be too burdensome. So we will be taking a closer look again at those knowledge pieces, the understandings and the skills and procedures, and then briefly look at some instructional considerations and how it can work in a framework of instruction, and some brief notes on assessment. And then Chris will carry through a bunch of wonderful examples and resources that I'm sure you'll find useful as you move forward with this curriculum. Once again, this organizing idea is energy. And as you know, the way the curriculum is structured, that organizing idea runs all the way through the science curriculum. Each organizing idea is structured in the same way, and each curriculum is structured in the same way. We do have the organizing idea, that's the broad understanding, followed by a guiding question, which limits down that idea a little bit more. In this particular case, we have, it's not what the effective climate is. I do have the wrong guiding questions and learning outcomes for kindergarten. I'll make that correction for grade 1. Of course, there is the knowledge, understandings, and skills procedures that we fondly refer to as the cusps in the curriculum. So we are taking a look at energy, and one thing I would like to do is take a quick look at how the organizing ideas unfold through the grades, especially through K to 1, because as you probably know, or maybe don't know, this science curriculum is a little bit different than the older one in that each grade's course was pretty much a silo of information that was taught at a certain grade, and then the next grade teacher did their science course, and the teacher after that in the next grade did a science course. This science curriculum is much more integrated in terms of what students learn in 1 year is expected to carry over into the next year. So you see a lot of ideas that were taught perhaps in kindergarten that students are expected to understand or have a good foundation of in grade 1 and grade 2 and so on. So by looking at the organizing ideas, you can see that at kindergarten, there's no organizing idea for matter, or for living systems or for scientific methods. There's another one that goes from grade 4 to grade 6 in that space, and that's not included in the curriculum for kindergarten as well. But when you do take a look at the learning outcomes across the board, you will see, for example, that there is a continuation of what is learned from one grade and sort of weaves into the next grade. For example, at kindergarten, we know with matter, or let's take a look at energy. Children are exploring the movement of humans and animals and objects at kindergarten. When it comes to energy in grade 1, students are looking at the direction and pathways and speed of moving objects. So not just how they move, but a little bit more specificity on moving objects. But you could see still the foundational ideas from kindergarten carry forward to grade 1. Grade 2 gets a little bit more specific. We're not talking about the movement of animals and objects. We're now talking about movement and behavior of light and sound, but again, talking about the movement of those the ideas. And then finally, we take a look at how forces in grade 3 affect movement of objects. So you can see how there's a build from year to year with the new curriculum. And there are some ideas for grade 7 and 9 that you can take a look at, if you will. Now we're unfolding this curriculum and presenting to you in sort of a milieu of all kinds of things. And I don't want to share these ideas of we've got artificial intelligence out there and genetic modifications. We've got climate change. We've got all these things happening in our world. I guess the question becomes, what does the future hold? And we don't necessarily know, but we do know that it's going to be different and it changes rapidly. And just as an example, of what we see coming up. I just wanted to share this little video clip for you. I've never seen this story, but it's amazing what robots can do at this point. Yeah, so it's quite amazing what's coming down the road in terms of robots, artificial intelligence, and so on. And while the future looks challenging in some ways, it's also, I believe, something to look forward to. I'm the eternal optimist. I believe that we as educators are going to play a key role in moving our students and everything forward. But the question becomes how? How do we do that? How do we take a curriculum and make it so that students learn what they need to know and what they need to be able to do to move on and face the challenges that face us in the future? And I think that that answer comes in with the whole idea of transfer. At the end of the day, I think we all believe that transfer is our collective goal, that we want our students to learn certain skills, certain attitudes, certain understandings, and carry them on to the future so that they can apply them to the everyday life. We want them to be successful in the world. And in order to do that, they have to take what they know and learn and be able to do and move it forward into their world, not only in school, but in their life or in their life outside of school. So the question becomes, what does transfer? We know that skills transfer. So the hard skills such as reading, analyzing, evaluating, perspective taking, questioning, those are all things that we would hope students take with them and become when they leave us. We want kids to be able to evaluate things and to question things, to question the validity and so on. Because there is so much information out there, we want them to do those things. But it's not just the hard skills that we want them to transfer. We want them to take some of those soft skills with them. And those soft skills are often referred to as things like collaboration, conflict resolution, perspective taking, and listening and empathizing. The deal, though, is that kids need practice in learning these skills. They need to be introduced to them, and they need authentic situations where they can learn these skills and do them. And that's where I think we come in as teachers, is provide opportunities where that can happen. That takes part in our planning and what happens in our everyday classroom. But then we've also got some other things that besides the skills that transfer. We know that concepts also transfer. And in this photo here, you can see a variety of concepts. You can see empathy, you may see inequality, maybe you see some compassion or hope. But at the end of the day, those are the two things that transfer very easily, and that's concepts and skills. And so the question becomes, what are those important understandings that we want students to transfer, and what are those important skills we want students to transfer as they move forward? And at the end of the day, how do we get kids to transfer? So let's begin with what a concept is really briefly. It is just an organizing idea of one or two words. It is typically a noun, and it has distinct attributes which make that thing so. So in the case here, we've got some chairs. They have distinct attributes which make them chairs, but they are also different than stools. A stool is a concept, but it has different attributes than a chair that makes it so. And so when we think about it, it's probably the idea that a chair is a piece of furniture made for sitting that has a back. A stool is also a piece of furniture made for sitting, but has no back on it as well. Whether it has four legs can be something debatable, because we know there's such thing as a beanbag chair. That is perhaps a chair, but it has no legs. So at the end of the day, concepts are those organized ideas and they have examples of them, and they have all these attributes that make them what they are. Concepts do range from broad to specific. For example, energy is a fairly broad concept, but as we move down into the specific courses or the specific organizing ideas for the grades, we get to more specific concepts. In the case of science here, we have energy, but we know that energy can be narrowed down to movement, and it can also be more specific to the types of movement and talk about pathways and the speeds of movement and so on. The more specific you get, the more knowledge-based things become, and the less transferable those ideas are. The more broader you go with your concept, the more transferable it is, and that results in the greater degree of those concepts showing up in a multitude of disciplines. So, for example, movement is fairly broad. It shows up in science, but we know it could also show up in art. And it can also show up as a concept in phys ed and dance and things like that. So the broader the concept, the more transferability, but the more specific the concept, the greater depth you get into the discipline. So they're both important. I want to introduce to you the idea of concepts because concepts do provide a focus when we're looking at something. We call that a conceptual lens. And so now you've got a brief introduction of what a concept is, that it's an organizing idea that has a specific definition to it and an attribute that make it so. Let's take a look at our curriculum through the conceptual lens of concepts. So our curriculum is generally organized this way. We've got the guiding questions. I've got the bright one this time, the learning outcome, and the cusps, the knowledge, understanding, and skills and procedure statements. When you look at them closely, there are many concepts built within this curriculum. For example, we could take a look at the guiding question, which reads, how can humans, animals, and objects move? Well, there are three concepts that jump right out at a person. We've got humans, which maybe is not so much a concept, but animals as a concept and objects as a concept. And what makes an object? What makes an animal? And what makes a human? There are certain attributes that make it so. So if you look carefully throughout the curriculum and all the cusps, you will see concepts jump out at you. And if you see in this next slide, I've highlighted things that are concepts. Again, some are quite specific and are almost knowledge-based, and some are quite broad and general. You'll notice that I have a couple of those concepts in brackets. For example, exploration is in brackets. That's because quite often our verbs and our skills actually have an associated concept with them. So when children explore, they're having an exploration. If something moves, it's demonstrating movement and so on. So when you do take a look at the curriculum, not only this one, but probably your other curricula as well, the science the math curricula, the language arts, the PE and wellness curriculum, you'll see concepts jump out at you when you look at those curricula as well. But there's a lot there, and the question becomes how in depth do we go with each of those? And if we spent a whole lot of time going into depth with each of those, we would run out of time definitely. And already this is a jam-packed curriculum. So what we want to do is we want to just get those anchoring concepts. In this particular case in kindergarten, we could take a look at some of the key concepts, and this one is movement, of course, movement type, position, location, and reasons for moving are the highlight concepts in here. There's often constant reference to animal, object, and human, and depending on where your students are at, animal may be a concept they already understand, and human, but that would be something you would want to find out for sure. And another concept that shows up often in this organizing idea is object, and you want to make sure that they understand what an object is. I'll get to the object in a little bit later on a different slide when we take a look at the concepts, more specifically the concepts themselves. The knowledge and the understanding components really house the concepts in this curriculum. When we take a look at the knowledge column, that is where the definitions of the concepts are kept. So, for example, that statement there, movement is a change in an object's position or location that happens over time. There's the definition of movement. What is movement? Well, the knowledge component will define what those key concepts are. And that's the same for the other curricula as well, and the other organizing ideas in science. Quite often you may find something without a definition, and a couple of things may have to happen. In this example, object is not defined here, but when you take a look at the kindergarten matter organizing idea, you will find that it is defined there, and it's defined as an object as anything that could be perceived using the senses. So if you don't see the definition there, look elsewhere in the curriculum guide. But another thing you may have to do is look at other curricula or other sites for definitions of those concepts, especially if they show up and appear to be major ones. But if they're major ones like this, they're likely going to show up either in another organizing idea or in another grade in science. You may have to Google that if you can't find them. The knowledge column not only houses the definitions of the concepts, but it provides examples of the concepts. In this case, there are no examples of what objects are. That was developed in the matter unit. So you can see again how the ideas and concepts move from organizing idea to organizing idea and from grade to grade. So there are no examples here. So you'd have to come up with examples if it's necessary to. But there is examples of the ways that objects move here. So when we're talking about ways, or what are some examples of ways objects can move? We're talking about straight lines, curves, and so on. If you want to, you could take a look at this. It's there for you. It may be helpful or not, but you may want to take a quick look at what are the key concepts in the grades, especially in this case, kindergarten to grade 3. This little chart may be useful for you. Whoa, there we go. It's organized in the organizing ideas. So we get a quick look at the guiding questions from K to 3, the learning outcomes, and some of the key concepts that are identified in each of those organizing ideas, those grades, to help give you an indication of what might be, you may want to really work at, so that students have strong understanding of those things when they leave the classroom for the next year. There's energy. So again, change, location, movement, position. Time is mentioned in one of the knowledge pieces, but I may take that one out of there. It doesn't seem to be a major concept, so we take it out of there. But you can see that movement continues on through the grades for sure. In fact, movement shows up in all of these, all the grades in the energy organizing idea. Earth systems, you can see some things like change continues on. Respect for land and care, I think, shows up in some of them, but not as main ones, I guess. The environment shows up in many of them as well. And so those are some of the things that also move on. When we take a look at the living systems, there is nothing for kindergarten because you don't teach that. There's the computer science. We know if you've taken a look at computer science, it may sound spooky, but it's really not too spooky for kindergarten. The key concepts are instructions and order and steps. And those are things that kindergarten teachers always do very well anyway, or talk about instructions and here are the steps and the order how you do things. And so you can meet some of your, a lot of your computer science learning outcomes by the regular things you do in your classrooms. If you take a look at that organizing idea, you'll see that it's fairly straightforward. It's going to go back to the slide presentation. So that if you want to take a look at that, that progression is there for you, and you will get a copy of this and all these handouts or documents that we're linked to in a second here. We do know that concepts can also be related to each other. Here are all the main ideas and concepts and understandings of kindergarten energy, the kindergarten energy organizing idea. It looks like there's a lot of information there, but they're fairly easy to read. And it just helps to provide maybe a bit of a map about where you maybe are with your organizing idea and where you have to go. In this organizing idea, we see that the key idea or concept is movement, and movement is a change in position or location. I added these yellow things on that are highlighted in red. Just as examples, because the curriculum doesn't move on to describe position or location. It is an understanding that they want students to know, but they do not provide examples of what a change in location would be. So we for that, I would think we'd look at words like beside. It's changed by moving away from towards something, or it was beside this, now it's beside that, and so on. And they're all relative concepts or relative change words. We could say that something has changed its position. It was standing straight, now it's sideways, or it's upside down or backwards. As I mentioned, those aren't in the curriculum, and I'm leaving a note with Alberta wondering why we're talking about position and location without getting too many examples. But movement can also have many ways. In other words, there's ways of moving. Objects can move in ways such as straight lines, circles, and so on. And humans and animals move in these certain ways. And certainly we know that if humans and animals are objects, that they could also move in circles and straight lines and back and forth and so on. So concepts do relate to others, and you can create concept maps to help to help put those ideas together and get a bigger picture. Let's use another conceptual lens, and look at the understandings in the guide, because at the end of the day, the relationships that I just showed to you on the concept map are really the basis of understandings. They're all boiled down to relating concepts together. In the guiding framework, understandings are defined as how facts and knowledge, and we know that there's the curriculum of the knowledge, or the column of the knowledge, so how facts and knowledge fit together in a logical and meaningful order. That is an understanding. And it's a little bit maybe ambiguous to understand just by itself, so I thought I'd just illustrate this idea with an example. In the organizing idea, we have these 4 concepts: location, object, change, and movement. So we could put these ideas together in a logical manner. We can say, for example, an object's location does not change without movement, or an object's location, change in location, is an example of movement, or perhaps an object's location changes as a result of movement. They all have some slight nuances that make them different. They all mean different things. But they're all composed of the same concepts. So there's definitely a difference between a single concept and a piece of knowledge as a separate entity. Location means one thing, an object means something, a change means something, and movement means something. And students may understand those individually of what they are, but when we try to put them together in some kind of relationship, that's when understandings start to happen, the broader understandings. In this particular case, while there can be many understandings built around those 4 concepts, the understanding that this organizing idea is focusing on is the bottom one, that an object's location changes as a result of movement. And we could see that show up in this particular, in the curriculum guide. That line exactly shows up in the understanding part of the curriculum with this organizing idea. An object's position or location changes as a result of movement. And you can see on the left-hand side under the knowledge, there's the definition of knowledge, and it says what it is. So knowledge includes those facts, symbols, and rules, and they are all put together into the understanding, and the understanding combines those separate pieces of knowledge into something broader and a little bit larger than just separate pieces of knowledge. And there's another slide that demonstrates that. Now, understandings themselves, because they are made up of concepts, they are also transferable. So if we take a look at one of the understandings from this organizing idea, that humans and animals move in various ways, we can ask students, is it true that humans and animals move in various ways? Do these pictures help describe that? And we would see that, well, after you've taken a look at different ways of moving and so on, that things can crawl or hop or jump or move in circles or fly, students should have that understanding that, well, yes, by comparing and bringing up different examples of creatures, we can see that they do move in various ways. So in summary, based on those 2 things, concepts do have definitions and examples, and they're transferable. they're deepened through the grades, and we've seen that as the through the transitions of the organizing ideas and the concepts in there. Concepts can provide a focus, such as a conceptual lens, and they can be put into relationship with each other. And when they are stated in relationship with each other, they do create what we call the understandings, and those understandings can be transferred as well. So let's move on to the skills and procedures. Again, this is a very short organizing idea, so there are not a lot there, but there's something I'd like to draw your attention to. First of all, a lot of the skills and procedures that I think in the background were expected to include are not in the curriculum. We see them as the competencies, the literacy, progressions, and numeracy, but they are skills procedures. And when you think about, again, moving ahead and transferring skills and into the future so that kids can be successful when they leave our classrooms and leave our schools, these are some of the things we want kids to be able to do. We want them to be literate for a variety of reasons, to evaluate and use information in ethical ways. We want them to be able to have the numeracy skills to handle their finances, to be independent when it comes to numbers. And we want them to have these other competencies like critical thinking and problem solving, and being creative, and being good citizens, and being feeling having that self-worth and that confidence with personal growth and well-being. And you don't see these things show up individually in any of the curricula, but it's expected they're infused in there. So when I'm talking about skills, I think it's an important thing to keep in back of the mind that when we plan a learning activity that just addresses the outcomes in the curriculum, we may want to bring, well, how can I tinker with this activity that I'm doing so there's more collaboration, for example? Or how can I tinker with this that allows them to be more creative by elaborating on something, or brainstorming something, or being creative, or being original with something? How can I include research and management in this activity? If you do go to New Learn Alberta, you'll see those competencies there. They're in the same area where the curricula are, and the competency progressions are here. And you'll notice that they are aligned. You will see that you can get the different competencies for different grades. So for the kindergarten students, there are certain ones, and for Div 1 and Div 2 and so on, there are different ones. So please do take a look at those. They are there, and they can be, unless we draw them out and include them in some of the teachings and learnings that we do, those skills will not necessarily be addressed. And so by all means, we hope that that's part of what you do, along with these other things here with literacy and numeracy. That in mind, the specific skills and procedures in the curriculum include these. But I'd like to just draw to your attention to a couple of tips that may help you with learning through this. First of all, you'll notice that the skills and procedures and the verbs are part of a larger statement. Half of it's a doing part, and the other half is the content part of the course. So for example, below we have the doing part highlighted in orange. Identify in a content objects that move, or identify how animals and humans move. So first of all, separate them. Make sure you can see where that verb is, and that's a fairly straightforward thing to do. But tip number 2 is to stop and think about what the statement's actually asking, because if we don't have that clear, the assessment part can kind of get, I guess you can assess it in different ways. Identify is one of those verbs that I'm going to ask you to look carefully at, because it can mean a variety of things depending on how it's used. For example, if we take a look at the first one, identify objects that move, it could be a recall statement, or it could be a higher level statement of having students understand the concept of objects that can move. If we're asking them to look around the room and identify objects that move, that's a very different question than to ask them, from memory to say some things that can move and not move. So it's that recognizing concepts that the word identify often means. Same with identify how animals and humans move. Again, a very different, depending on how you read that, identify can mean two things. It means to recognize. And so when if I see an animal moving, I can recognize the movement that animal's creating. I can identify it. Or do I just identify from recall? I know that horses, for example, gallop or run. So there's a little bit of difference there, and that's going to depend on, and with that difference, you're going to assess differently and so on. So we want to make sure that those verbs are clear. Another one is, another example is the verb examine in this skills and procedure statement. Examine the reasons that animals and humans move. I'm not too sure if it really wants us to examine the reasons. If we were to examine the reasons, we would be looking at the reasons and taking a close look at them, but I'm doubtful that that's what it means. I think that this word examine really may mean to explain the reasons that animals may move, or do you recall the reasons that animals can move, or let's discuss the reasons that animals move, but I'm not too sure the intent is to actually examine the reasons themselves. So that's why tip number 2 is important, not only for this organizing idea, but for all the organizing ideas in science, to make sure that you have some clarity with what the word means, because it's going to really change up on the kind of assessment that you do. And finally, tip number 3 is that there are some skills and procedures that are more important, I think, than others, that they begin in one grade and they carry through, or they're the larger skills that are necessary, not only for science, but for other subjects. For example, evaluating or summarizing or comparing. Those are some big skills that students need to carry with them in any grade, in any subject. And for those, I suggest we do something called a direct teaching of skills strategy. Observation is one of those skills that show up quite a bit throughout the elementary curriculum, and it shows up in the the 4 to 6, not as a specific skill, but it's embedded in the larger skill of doing an investigation, because observation is one of the steps in investigation. So it does show up in kindergarten. And so to take the time and to maybe pay some attention to it is going to serve the kids well as they move to the grades. And so one way you may want to consider it, and not follow this exactly, because kindergarten is a little bit, may not follow this procedure exactly, but I think the idea of teaching something directly, especially the skill, may be helpful. And the direct teaching of skills looks something like this. The first step is to define the skill, like what is observing? What does it mean? And students, well, you want to share this with students. It means noticing as much as possible about something by using our senses. There's a concept related to, like I said, when you're observing, you're making an observation, and an observation is what we notice with our senses. Then what do we do? Like if we're asking students to observe, what does that mean? How do we observe? And here are some possible steps that a student that you may want you to ask your kids to do when they're observing. Well, if we're making an observation, we remain still and quiet, and we notice whatever we can with our hearing, with our sense of hearing. Now, in the matter unit, the senses are being covered. So again, that would be something that you would want to make sure that kids understand before you even get into talking about observing. What are the senses? What do you notice with your sense of sight? What properties do you see? What's moving? What's not moving? What's changing? What's not changing? So just honing in on what we see. And you can see there's different questions there that would be part of the procedure of observing. After you've done that as a teacher, sort of laid out the steps with any skill, not just observing, but with any major skill, then you take a look, well, there's going to be some concepts embedded within them. For example, in the list here, I have highlighted that properties, movement or moving, change, those are all concepts that are part of the steps. So I want to make sure that kids know what they are. I want to make sure they know what the senses are, what hearing is, and so on. The organizing idea of matter talks about properties. So I may include that in my list if we've talked about matter and properties so far. And now we're talking about movement with this particular organizing idea. And then what I want to do is, after I've identified those concepts, I want to make sure that they understand them. An example might be this, for example, what's an observation? I could use a concept attainment lesson. You're familiar with those, where an observation is sort of taught in an inductive way. So this particular activity gets kids, and it doesn't have to, it may be a little bit different for kindergarten, but it's there's an example and non-example of a statement that's an observation when it comes to what is seen. You can see how this unfolds. I quickly roll through it. Then I move to the sense of touch. When we're looking at textures, that there's an example of an observation that is a plant is prickly. That's an observation, but I think this is called a burr. I'll have to get that fixed up. That's not an observation. The bark is rough. The tree is an old tree is not an observation, but a bark is rough is. And you can get the idea of how we go through the different senses. We do the same for taste, and we can do the same for smell, for example. You may have some real things in the classroom. And then we move on to listening. And finally, we develop that understanding that the concept, an observation is something that we notice with our senses. So once again, then going to this, we know what the kids know what an observation is. So how do we do it? Here's the steps of how we do it. So that's just one example of maybe where this direct teaching of skills strategy becomes important. We sometimes just take for granted that kids know how to do things, until we could pause and teach directly so we can give them feedback on how they're doing. If their observation was good, were you paying attention? Were you still? Were you quiet? We can give them that kind of feedback that will help them through the skills. And here are all the skills in this whole organizing idea, not a lot of them, but we're getting kids to move objects, identify objects, and so on. And they're not, again, the key one there for me is probably observe, and the whole thing of identifying in terms of finding examples. Okay, so identify objects that move is looking for an example of a concept, an example of an object that does move. Move object in a variety of ways. Again, they're demonstrating their understanding of a concept of zigzag. They're understanding their concept of curve and so on. So that's what those are all looking for. Now, when it comes to all the skills in kindergarten science, I'd just like to draw your attention to this chart really briefly. If you take a look at these are all the K-3 skills and procedures by grade. If you take a look at kindergarten column, you'll see the key words here, the verbs. There are a multitude of them. Identify shows up 8 times as a verb throughout the grade, throughout the grade or kindergarten science. Discuss shows up once, describe several times, 3 times, but then you'll see that there's a lot that just show up once. And so you don't want to do the direct skills teaching strategy with all those. You want to point out, you want to do that with the biggies. Identify is a tough one because, like I said, it can mean different things, but you may want to take time to really focus on, well, at kindergarten, what some things are important to discuss, because the discussion one is hugely important as you go through the grades. And once kids can start understanding what discussion is, what some of the basic requirements are for a good discussion, that can be built on grade by grade. Same with describing. It shows up in kindergarten, and it really, really expands into grade 1, especially up into grade 3, where kids are describing things with their senses, describing what they see, describing what they measure, describing what they observe, and so on. So you can refer to that if you want. That's something there. Now, what I've done is I highlighted the yellow columns I should add are all those things that do show up in each grade from K to 3. So you can see some of them are quite common compared to the whole list of other ones that that aren't necessarily shared between the grades. So those are, to me, would be the biggies that you'd want to focus on for sure when it comes to really spending a lot of time teaching those skills directly. So again, some of the key skills are those that I mentioned. The competencies I mentioned, they're there. They don't show up in the skills and procedures, but boy, oh boy, collaboration is important, and all those things are still important. So how can we infuse them into our lessons? Imitate does show up there. I highlighted it because it's I think it's the only time it ever shows up in the whole curriculum. And I think getting kids to imitate model is something probably done at the kindergarten level, because I'm sure it's going to be a little bit tricky to get them to write down their thoughts and so on. So here are the key things then. Knowledge are those facts and symbols and principles and concepts. The understandings are how those knowledge pieces come together. And the skills and procedures are what students do to demonstrate their knowledge, what they do to demonstrate their knowledge of concepts, for example, so identify types of movement, or demonstrate their understanding, the whole collection of concepts together. So the question becomes, well, then how do we know what each of those pieces are? How do we get them to transfer? How do we get them to transfer concepts? How do we get them to transfer understandings and skills? And so I'm going to just quickly review with you once again the Hattie approach. We're talking about surface, deep, and transfer learning. At the surface level, this is where we introduce those individual concepts and individual skills. So we're taking a look at movement or object. We introduce it here. What is an object? What is movement? And we talk about all those sort of separate pieces of knowledge and develop them. You'll notice that I have concept as a two-dimensional box and as a cube. That's because the concept is more than just its definition, which would be two-dimensional and just that piece of knowledge. We want them to be able to see and recognize examples of those concepts or generate concepts in their environment, in their world as well. Same with skills. It's not just a matter of knowing what a skill is, but actually a matter of doing that skill in different contexts and becoming competent in that skill at the surface level. So that's why doing the direct approach to teaching is a good one, because what you're going to be doing at that point is you can just be using all kinds of different contexts to teach that skill, and not necessarily course content, so they can be competent in that skill, and then you have them apply it to their course content or their course content. And that's where the deep portion comes in. This is when students start making connections to those concepts. So instead of individual pieces, now we make those understandings that we gave examples of before. And those understandings, like I said, do transfer. So the different colors back here represent the different content that you may use to look at those understandings. So you may use very familiar content to begin with, and then you move on to more distant or unfamiliar content. Sometimes course content to be used here, it could be used in the whole transfer part. And transfer really is then, and you could see the different shapes and colors again. The understanding is the same, but what is happening is the content is changing. So you're providing kids to demonstrate their understandings in different contexts, or use their skills in different contexts. So for example, where you may learn about the different ways of movement in science, as zigzags and curves, maybe you can apply that to something phys ed, or maybe you could transfer that to something in art, or maybe you could transfer it to something in dance. And so surface deep transfer is the progression that we would move to get kids to transfer. We get a good solid foundation. We give them some guided practice to develop that, they create their deep understanding, and then we have them become more independent and transfer that down the road or down to different contexts. There are a variety of different instructional approaches. I'm not going to go through this with you. They will be available on the different slides or the slide deck that you can have. I see I'm getting a little bit over time, so I'm just going to move on quickly. But there are different activities that you can do to get students to become competent in the surface understanding, their deep understanding, and transfer understanding. And when it comes to assessment as well, once you identify the concepts, you may want to do some pre-assessment to see if the kids know what those concepts are by providing examples of them or recognize them in their environment. If they don't, then we do the teaching, and after do the instruction, we do some assessment to see if they're ready to start combining them into their understandings. And if once they start demonstrating those understandings, we can move more into the transfer modes and so on. And then that's where perhaps our summative assessments will show up. So we formative assess all throughout the process until we get more into the transfer mode, when we know that kids are competent in their skills and competent in their understandings. On that slide deck you'll have available to you, there are some questions you can ask to see if they're ready to move from surface to deep. So for example, can students state the definition and meaning of concepts in their own words? If they can do that and then provide examples and identify examples, we know that they're ready to move to the deep. And same with the deep, there are some things you can ask students to do to demonstrate that they have a deep understanding that they can then move in to the transfer zone. With that in mind, then, what I'm going to do is share with you a video that Chris made earlier of some examples. It's about 20 minutes long. You're invited to stay and watch through it, or you can access this video later. At the end of the day, all I ask is that when you do take a look at this, is try to look at the ideas that Chris shares with you through the lens of surface deep transfer. Is she developing an individual concept here? Is she working with an understanding? Is there a skill that's being demonstrated here and being practiced or introduced? So if we're intentional in how we look at examples and lessons and how we look at resources through the lens of where students are at their learning of surface deep and transfer, I think we'll move more towards helping kids get what they need to understand and be able to do, and carry them and transfer those forward in their lives outside of school or into the next grade. So with that, then I am going to share with you Chris's a video. I will stop the video and loose things up at the end to see if there are any questions, if you have any, and then we'll end our presentation there. So here are a lot of really good examples and activities you could take with you as you work your way through this organizing idea.
Hello, everyone, and it's so good to see you. And my apologies for not being able to join you at our last session. It's been a real pleasure to be working with you all and kind of journeying through all of the kindergarten science that there is. We will be offering more, so hopefully we'll see you back again. But anyway, we're on our last one today, which is looking at energy. And so what I'd like to share with you today is quite a bit shorter. There isn't a lot to this organizing idea, but the potential for us to tie it into so many other activities that you're doing in the other subject areas is super, super high. So hopefully I'm just going to be giving you some ideas that you can walk away with and say, okay, I could use that one or not this one. Remember, in the short time that we have, I can't unfold an entire lesson plan unit for you, but I can maybe give you an idea of how you might unpack this and what you might do. So again, hopefully you get some ideas from this, and we'll go from there. So I've kind of titled it Movement in My World. Let's get going, because really it is about movement, and can the students identify different kinds of movement? Specifically, we're looking even at the pathways. The kindergarten and grade 1 is quite similar. They link together quite strongly. So there's quite a bit of overlap for those of you that are teaching split grades. So that part of it will make it very easy for you. But I called it Let's Get Going because I really think it has the potential of us tying it into just some healthy living and activities at the same time as I'm learning about the different kinds of movement. Okay, so let's get going. So I'd like to kind of divide it up into two areas. One of them would be, let's just look at what moves and what doesn't move, and maybe describing what those
I'm sorry, I'm not too sure what's going on. I will, it looks like it's rebuffering here, so just hang tight. Okay, I'm not too sure what's going on. I'm gonna go escape. Pause, 209. Oh boy. This is one of those things they don't expect to happen. Well, I'm going to pause this. It appears there's something that's making it difficult to get through. I'm going to stop sharing, and I am going to answer a question that was on there. Listen, this video will be made available to you, and all the resources and everything that are in that presentation are available to you. I'm going to maybe just finish up here. If you could see this link here, it will be in the slide deck, but I'll also put in your text right now. It's the Moving Forward curriculum that will have Chris's video and will have all the other resources. What you'll need to do when you go here is create a free account if you haven't already, and log in. I'm already logged in. Once you're logged in, you can go to the subject areas, and here's where, and science is located there. It has all the grades, all the presentations that Chris and I have done up to this point. If you go to kindergarten, you'll find that there are the different sessions. Session 5, you can see, is not loaded up yet, but the session 3 for matter and earth systems are there. And all the accompanying resources are with that, along with the videos that were created with this as well. So this is where you will find all the resources connected with this session, and any accompanying videos, including Chris's. So I really do apologize for that. What I'm going to do is I'm going to put this into the chat right now and get it off to you. Here we go. So there's the link, if you don't have it already, that will have this Chris's presentation on there as well, with all the other resources. Again, I apologize. I'm not too sure why it's not working. I'll just double check that and see. I'm going to go to stop recording here. And